Good day, dear students. Today we are going to study acid-base balance role of the kidney. What is the challenge in front of the kidneys? The kidney has to reabsorb all the filtered bicarbonate. The filtered load of bicarbonate is GFR into plasma concentration, that is 180 liters per day into 24 milliequivalent per liter. That comes down to 4,320 milliequivalent per day. So it has to reabsorb all the filtered bicarbonate. In addition, the kidneys has to secrete this much H plus because bicarbonate is reabsorbed by combining by secretion of H plus. So it has to reabsorb 4,320 milliequivalent per day of H plus an additional 80 milliequivalent per day of non-volatile acids. Remember, non-volatile acids are acids which cannot be excreted by the lungs and they have to be handled only by the kidneys. Now, I am going to talk about 4 at play of the security personnel. The security personnel with dandas only, the security personnel with a gun which does not fire, a gun which fires but does not hit the bullseye, and finally a gun which hits the bullseye. So the kidney basically reabsorbs all the filtered bicarbonate. It secretes hydrogen ions and it forms new bicarbonate. This is the way it maintains acid-base balance. Reabsorption of filtered bicarbonate is to the proximal tubule, thick ascending limb, and early distal tubule is by combining with H plus. And in the late distal tubule and cortical collecting duct, hydrogen is secreted by an active pump mechanism. So new bicarbonate is generated. Please remember, new bicarbonate is generated. 85% of the filtered load of bicarbonate is reabsorbed in the proximal tubule, and 10% is absorbed in the thick ascending limb of the loop of Henle. The rest is reabsorbed in the late distal tubule and the collecting ducts. Now we start with Act 1, the security personnel without a gun. So this is the story in the proximal convoluted tubule, thick ascending limb, and early distal tubule. Here what happens is that the first step is that CO2 combines with H2O to form carbonic acid, and this dissociates into hydrogen ions and bicarbonate ions. At the same time, there is operation of the sodium-potassium ATPase pump on the basolateral surface. As a result, by a secondary active transport mechanism, hydrogen is secreted into the tubular lumen. Please remember, secondary active transport is secondary to ionic gradients created by primary active transport. For example, when a motor lifts up a heavy weight, that is primary active transport. The motor, that is the pump, sodium, potassium, ATPase. Now, if this weight is put on a pulley at the other end of which is a child, and a child is lifted up, that is secondary active transport. Here the child is H plus ions. The important point is that for each H plus secreted, one bicarbonate is reabsorbed. The reabsorbed bicarbonate is different from the filtered bicarbonate. But what is the limitation? The limitation is that the hydrogen ion concentration can be increased only 3 to 4-fold and the tubular fluid can be brought down to 6.7. We need to bring it down lower. So this is just like having police security personnel without any gun. Now we come to Act 2. That is the security personnel with a gun that does not fire. This is the story in the intercalated cell. The intercalated cell is the hydrogen secreting cell in the late distal tubule and the collecting duct. The main cell in this part of the nephron is the principal cell, and the intercalated cell secretes hydrogen ions. You can see by the same sequence of events, slightly different. Here, hydrogen ion is secreted by a hydrogen ATPase and new bicarbonate is being generated. So bicarbonate is not filtered and excreted, but new bicarbonate is being generated. The important thing is that it accounts for 5% of the H plus secreted, and hydrogen ion concentration can be increased 900 fold. Tubular fluid can also be brought down to 4.5. And why do I say it is having a gun, but the gun is not firing? So the kidney is reabsorbing bicarbonate, secreting hydrogen ions, also secretes an H plus ion compared to the bicarbonate reabsorbed. So is this not enough for maintaining the acid-base balance? Just having a gun is not enough, dear students, because in the free ionic form, only a small percent of H plus can be excreted. See this. If hydrogen ion is excreted as H plus, per liter of urine, only 0.03 milliequivalent of free H plus can be excreted. So to excrete 80 milliequivalent per liter of H plus, one has to form 2,700 liters of urine per day. To excrete 80 milliequivalent of non-volatile acid in the ionic form, one would need to form 2,667 or roughly 2,700 liters of urine each day, which is not feasible. So this is like having a gun which does not fire. Still the police is not working. Then what is the solution? The solution is by the buffer system. So the first buffer system is firing, but still it is not enough. It is still not hitting the bullseye. As I said, the solution lies in the buffer system, the phosphate and the ammonia buffer system, which results in generation of new bicarbonate also. The phosphate buffer system, this is the same sequence of events like in the proximal tubule. Here, sodium hydrogen countertransport occurs and hydrogen combines with the phosphate buffer. Also, phosphate buffer becomes concentrated in the tubular fluid. Its pK is 6.8, which is close to the urinary pH. And there is a net gain of bicarbonate. The limitation is that very little phosphate is really available. So only 30 to 40 milliequivalent per day is available for buffering H plus. So still the policeman is firing, but it is not hitting the bullseye. Finally, hitting the bullseye. This comes with the ammonia buffer system. Ammonium is generated from glutamine, which comes from the metabolism of amino acids in the liver. And this glutamine generates 2 NH4 plus and 2 bicarbonate. So for each molecule of glutamine, 2 bicarbonate are generated and 2 H plus ions are secreted. So this accounts for 50% of the net acid secreted and 50% of the new bicarbonate generated. So now we have hit the bullseye. So for acid-base balance by the kidney, remember the 4-act play. Security personnel without a gun with lathis only, the security personnel with gun, that is the intercalated cell, the phosphate buffer system that is still not hitting the bullseye, and the ammonia buffer system which hits the bullseye. Thank you and have a good day.